the Modoid. Okay? But by the way, the Modoid concept I actually published. Okay? Actually, this new concept called Modoid. Mode to Modoid. So let's consider this example. It's a timeline. In typical conference, people come. This is a registration desk, and people can compute where is the mean or median. But in this case, mode is people are very interested in because you want to place more people, more volunteers. Okay? Sometimes people don't come. Sometimes people come, but peak time, right? So people are interested. But actually, I published this paper in the Flares conference last year. Okay? But 33 was the COVID-19, so it didn't. It was on Zoom only. But last year was the you can come or you can join the Zoom. But what's the worst? There was if you recall, there's a pipeline problem. There's no gas problems. Okay, I was driving down to Florida, and then I looked at the gas station. There's a huge line of cars, so I returned back home. So this is maybe I watched the Zoom, and that's the frequency of the people coming to the registration desk. Okay. We can actually compute what's the mean and median, but what is the mode? We have a problem. What is the mode here? Okay. But if you run the program, it will actually give you an answer. But what would that be? So we have that problem. Okay. So let's define what the mode is. Mean, you can just input this data set. For mode, you must compute the histogram. Okay. And you can find the max, which is 4. But that's not what we want. We want argmax of that, which is the argument that makes the value max, which is the 3. That's the mode. And this concept was Carl Pearson actually named it maximum or limit in 1895. And he said data distribution must be unique model. But can we assume actual data set, real world application? Can we assume that? Answer is no, we cannot. That's the problem. If it's multi-model, each one return conventional mode, each one return data. I'm going to show you how we can return something like this, proposed Modoid. Okay. And also, in the past 10 years, I've been giving homework assignment to test the programming skill of their students and implement this. And there are some students that actually use the packages and actually returns that guy as the mode over there. And people got shocked. Students got shocked. And if you want to use the package, test at least more than 5. And we test more than 20 famous. You can name it machine learning, data science, or any statistics packages you use, they all return that guy. Okay? So that's a problem. And let me show you another problem of the mode, the current mode. If you have a real value data, how you quantize it? If you quantize it as 2, 4.5, quantize it 3, etc. Different quantization values or bandwidths may result in different modes. That's a problem. How do you resolve that? So, in order to solve those problems, let me introduce you concept of density. Dense. Okay? Within radius R. Okay? For the 1, radius 1 would be 6. For 4, radius 1 would be 9. So can you pick something which is the density is higher within that radius? So we can have an algorithm. First, let's consider this data set. And if you set the radius to be 0.45, we have times. 3 values have a frequency of 3. Now, those candidates we can recompute by increasing the radius by slightly and 2 left. And finally increase to the 1.05, we have a 1. That guy is what? Highest radius density, and that's the mode. And let's call it Modoid to distinguish from mode, conventional mode. So we have a simple definition. Okay, for this simple definition, there's a caveat to consider. Okay, in the worst case scenario, if you keep increase the radius by one, slightly, they always start and actually equivalent to the entire data set size. Then this caveat should be considered, so you should add one more line over there. Okay, that's when you implement. Okay, so what in this case, conventional mode gonna pick 0 as your mode. This one gonna either 2 or 3 as your proposed mode. Okay, tie down 2 or 3 gonna have an equivalent. Now, in the TD sequence, we have a data set represented not vectors. Okay, once again, it's very important. Okay, you don't represent the data as your vectors. Okay, then what do you do? Okay, if we have a pairwise distance matrix, what do you do? Okay, I want you to scan through. Okay, radius 0.01. Whoever smaller than that radius, counting, and we have a 6. That's the maximum. And 3 ties. So reduce it. Okay? And then increment the. Okay, I'm sorry. Oops, sorry. Increment the radius, and then count it. Oh, now we have 1. The gorilla is the Modoid. By the way, initial radius happens to be, suppose, it's not a ghost, by the way. What if initial radius is 0.17? Okay? If you count it, the pig is not the gorilla. It's actually Monoid and Canis. So it is like if you have make radius too big, okay? And these guys might show up as a mode, but if you start from the small, you can actually avoid this kind of case. Okay? We prefer to choosing initial small radius, start from there is very important. And automatically finding how do you find the radius to start with is probably one of the open problems. Okay? Time 3 minutes. I think it's a good time for the questioning. Okay, I'm gonna stop right here. And